Have you ever looked up at the night sky? A vast, dark ocean sprinkled with countless tiny points of light? Have you ever felt a sense of profound wonder? A feeling of being both incredibly small and intimately connected to something immense? It's a feeling shared across millennia, like a silent conversation with the cosmos. Each star is a distant sun, potentially warming its own family of planets. Out there, could another being be looking back, seeing our sun as a faint star? This question shapes our place in the grand cosmic scheme. For generations, we have aimed our most powerful instruments at the silent heavens, listening. We've dedicated lifetimes of scientific brilliance and strained the limits of our technology, all for a signal that may never arrive. So, the question persists, a profound echo in our collective consciousness. Why do we pour so much effort, so much ingenuity, into this search for others? The reasons are as complex and varied as humanity itself, a tapestry woven from our deepest psychological and philosophical threads. Is it a profound sense of cosmic loneliness, a yearning to know we are not the sole occupants of this vast, silent stage? Or is it the pure fire of scientific curiosity, the same impulse that drove us to map our own planet? At its core lies a deep, primal desire to know our context. Throughout history, every great discovery has redefined our place in the universe. We once believed we were the center of all things, until science showed us we orbit an average star in an unremarkable corner of a vast galaxy. This search is the next logical step in that humbling journey. Imagine stumbling upon a cosmic library, yet you are only permitted to read a single page from a single book. That page is beautiful, intricate, filled with the epic tale of life on Earth. But it is still just one page. We are left to wonder, what do the other pages contain? Finding another intelligence would be like turning to that second page. It would instantly transform our single data point into a trend line, offering a new perspective on everything. Suddenly, our biology, our history, our art, and our religions would be seen not as universal truths, but as local customs. That second page would begin to answer the ultimate question. Is life a precious, fragile accident, a one-in-a-trillion fluke in the cosmic casino? If so, the responsibility to cherish this singular spark is immense. Or, is life a robust and common feature of the universe? A cosmic imperative, destined to emerge wherever the conditions are right? If that's the case, the cosmos is not a barren desert, but a vibrant living ecosystem, and we are just one voice in an unseen choir. Ultimately, this search is a profound extension of our evolutionary journey. Our ancestors pushed over the next hill and crossed the next ocean, not just to survive, but to connect. We are an inquisitive, social species. Now the only frontier left is the cosmic ocean. We listen for a voice in the static, hoping to end our splendid isolation and join the galactic conversation. How do you find something light years away? A tiny world lost in the blinding glare of its parent star. The challenge is immense. To succeed, you must become a cosmic detective, sifting through faint whispers and fleeting shadows for the telltale signs of life. Our primary tools are our extended eyes, telescopes. On the ground, we build them on remote peaks, far from city lights and above the thickest layers of our atmosphere, patiently gathering ancient starlight. But for the ultimate view, we go to space. Above the distorting atmospheric veil, orbital observatories deliver astonishing clarity. The James Webb Space Telescope is a game-changer. By seeing in infrared, it pierces cosmic dust to witness planetary birth and, crucially, analyze the chemical makeup of distant worlds. This analysis happens when a planet transits or passes in front of its star. Starlight filters through the planet's atmosphere, and a spectrograph splits that light into a rainbow of colors. Gases in the atmosphere absorb specific frequencies, leaving a unique barcode of dark lines. These lines are chemical fingerprints, revealing the atmospheric composition of a world we can never visit. And it's here we hunt for biosignatures. We look for water vapor, the solvent for life as we know it. We search for oxygen, a reactive gas constantly replenished by photosynthesis on Earth. And methane, a potential byproduct of microbial life. Finding these gases together would be a powerful clue that an active biological process is at work. But we don't just look, we also listen. The cosmos hums with natural radio waves from pulsars and quasars. Our radio telescopes scan this cosmic static for a technosignature, a signal that stands out. It would likely be narrow-band and structured, the hallmark of technology, a deliberate broadcast or the leakage from a civilization's own communications, just like our signals constantly spill out into space. Finally, while telescopes search afar, our robotic emissaries explore closer to home. They are our hands and mobile labs. Rovers on Mars sift through ancient riverbeds, while future missions will probe the oceans of icy moons. These missions are crucial, helping us understand the limits of life and refining what we look for in the great expanse. In 1960, astronomer Frank Drake initiated Project Ozma, the first systematic search for extraterrestrial intelligence. It marked a pivotal shift from passive wonder to active, scientific searching. Drake listened to nearby sun-like stars at 1420 MHz. This wasn't random, it's the emission frequency of hydrogen, the universe's most common element, a theorized universal hailing frequency in the cosmic static. No signals were found, but it was a profound turning point. We started actively listening. The question of, are we alone, had become a testable scientific hypothesis. Inspired by Ozma, the search expanded. Larger dishes, broader searches, and more powerful computers followed, allowing astronomers to scan ever wider patches of sky. Then, in 1977, a powerful 72-second narrow-band signal arrived from Sagittarius. It was so striking that astronomer Jerry Amon famously scrawled "Wow" on the printout, giving the famed signal its name. It perfectly fit the profile of an interstellar beacon, but it has never repeated, despite decades of follow-up searches. It remains a tantalizing, unsolved mystery. Today, Breakthrough Listen scans 1 million nearby stars and the 100 closest galaxies across billions of radio channels. It's the most comprehensive search ever undertaken, gathering immense datasets for analysis. And the search isn't limited to radio. We also seek optical technosignatures, brief but powerful laser pulses. Such a focused beam could be an efficient interstellar lighthouse, a different kind of message entirely. And yet, the cosmos remains quiet. This profound silence is, in itself, a crucial piece of data. It speaks to the Fermi paradox. Where is everybody? Each silent observation narrows the possibilities. Despite the odds, the search continues, driven by what the discovery would mean for humanity. It's a quest for context and our place in the universe. Our curiosity is louder than the silence. We seek worlds that are just right, in the habitable zone, not too hot, not too cold, just right for liquid water. Too close and water boils away. Too far and water freezes solid. Liquid water. Biology's ideal solvent, abundant in the cosmos. Other liquids could work, but water is chemically superb. Too small and a world loses its air. Too big and you get crushing gas giants, no solid surface. Ideal. A rocky planet with an atmosphere and magnetic shield. A galactic habitable zone likely exists too, not too near supernovas, not too metal poor, a just right ring for life. For most of history, we knew only one planetary system, our own. In 1995, the first planet around a sun-like star was found, 51 Pegasi b, a hot Jupiter. The floodgates opened. The census began. Kepler watched for tiny transit dips. Thousands of worlds confirmed. More await. From super-Earths to planets with 2 suns, even rogues between stars. Dozens sit squarely in habitable zones. TESS finds nearby targets. Webb probes atmospheres for biosignatures. We are on the cusp of detecting telltale chemistry. The census is becoming a character study, edging us toward an answer. While we listened, we also sent messages of our own. Time capsules for eons. Pioneer 10 and 11 carried plaques with who we are and where we come from. The Voyagers traveled farther than any human-made object. Voyager 1 entered interstellar space. Each bears a golden record. Images, greetings in 55 languages, Earth sounds, and music. Curated under Carl Sagan, it reflects our bodies, our lives, our world. The odds of discovery are tiny, yet sending them made us ask who we are. What should represent humanity? They remind us we share one beautiful planet and a common story. Imagine the search succeeds. A signal is detected, confirmed, decoded, or Webb reveals undeniable signs of a living world. One of humanity's most profound moments, a turning point shared by everyone. Our perspective would shift forever. The implications, philosophical, religious, would be immense. Some would fear, others would feel affirmed by a creative universe. A golden age of research, exobiology, alien linguistics, new sociology. Yet caution, the universe might be dangerous. Broadcasting could be risky. Any starfarers likely overcame self-destruction. Perhaps wise, perhaps not. We do not know. That uncertainty keeps the question compelling. In 1990, Voyager 1 turned to photograph home from 6 billion kilometers away. Earth, a mote of dust suspended in a sunbeam. On this tiny dot, everyone we have ever known lived out their lives. Our planet is a lonely speck in the great cosmic dark. The more we search and hear silence, the more precious our world becomes. We are the guardians of consciousness here. We must care for each other and our home. Whether alone or among many, the quest itself elevates us, our curiosity, intellect, technology, and hope.